Hello. Hello, everyone.
Hello.
How's it going? Yeah, super bright light, but that's okay.
That's good.
Hey, we are Josh and Dorian from Pagoda and Near Protocol. We're here to go over a little bit of a workshop talking about building Near smart contracts with JavaScript. We'll go over a little bit about what Near is, what Pagoda is, and then, yeah, this is kind of designed to be an educational workshop session where you can kind of code along if you'd like. So if you have a laptop, want to code along with us, absolutely, we encourage that. But yeah, hopefully we'll take you from start to finish on building smart contracts and getting started with Near. So, hey, I'm Josh. This is my avatar on Discord. So if you're online trying to look for someone or trying to chat with someone in our Discord and need help, this is me. I started my career in IT in 2003, and then in 2006 I actually traded web design for glass blowing lessons. And in 2015 I quit my tech job, did glass art full-time for many years, and then in 2020 I returned back to tech in kind of a creative role by doing software development to kind of itch that creative juice or that creative itch that I had in that space. And then in 2020 I joined Near on the developer experience team, and now I work on DevRel with Dorian.
Oh. And I am Dorian. I also work in the developer relations team under Josh. I actually came up to Near by creating a web series called Blockheads, and now I run this web series called Near Bytes. It's a quick look into developer spaces in Near ecosystem, so go into our YouTube channel and check it out. And also, I used to be a mechanical engineer before I worked in this space. So yeah, I'm a mechanical engineer turned developer. And fun fact about me, I live here in San Francisco, and I play on a dodgeball team every Monday.
Nice.
So yeah.
Cool. So what is Near? It's a layer 1 blockchain. It also is proof of stake, and it's certified carbon neutral by South Pole. It's something I'm really proud of. Everything, all the validator nodes, and also all of the carbon output that our collective does, travel, computers, everything is offset by tree planting initiatives through 3 different ones through South Pole, rainforest protection initiatives as well. So it's something I'm super proud of and stoked to be a part of. We're almost infinitely scalable through sharding. We actually just launched phase 1 yesterday. So now we have validator nodes that have increased. We have chunk producers. A little bit more about that if you go to near.org/blog. I believe there's probably a little bit more information on that. But yeah, we're finally in phase 1 of sharding as of yesterday. Super stoked about that. And quick, we're about a 1 second block production time. So interacting with the chain, you can get results. You can manipulate state, get state back really lightning fast. And we're also interoperable with Ethereum using the Rainbow Bridge. Near's engineers were the first ones to create a trustless bridge to Ethereum, something, again, we're super proud of. And they've actually spun out that team to create Project Aurora. And what that is it's an EVM on Near. Basically, if you have a smart contract written in Solidity and you want to launch your smart contract on our platform, you can actually take that code, very minor adjustments to it, and upload it to a smart contract that's deployed on Near. It's like a little mini Ethereum universe that exists in a smart contract on Near Protocol. It's super, super cool. And yeah, mention a little bit Pagoda. So people are like, what is Pagoda? What are we doing here? So brief history, 2017, Near Inc. started as an AI company by co-founders Alex and Ilya. They worked on that for a little bit, and they wanted to get people to participate in that through paying them with blockchain, and realized kind of quickly it was difficult, especially in 2017, to do these types of payouts. And they found blockchain development to be really difficult. So they decided, hey, let's pivot. And in 2018 decided to become a blockchain company that was going to focus on developer experience, ease of use, and also end user experience. Just trying to bring this technology to people in an easy, more grokkable way. So in 2019, they built mainnet. 2020, they actually shipped it. They maintained the validator nodes and then gave it to the community so that it's entirely community run, all the validator nodes. And then in 21, Near Inc. and the engineering team behind it became Pagoda with some spin-offs. Again, like I said about Project Aurora, that was a spin-out. There was an NFT spin-out, Satori, Proximity Labs, DeFi project that was also spun out from that. Yeah, and it's just an effort to kind of further decentralize. So we're not really like owning it. We're major contributors to Near Protocol, but we want to encourage the community to participate and contribute to the source code, and yeah, just really want to kind of be less centralized. And then also in 2022, we launched Developer Console or Pagoda platform, and trying to be just a really easy Web3 platform for people to onboard, kind of staying true to the initial plan in the beginning of being very easy for people to onboard. And then hopefully in 23, we can be the primary entry point for Web3 builders. And that's kind of what we're going to talk about now is our plan for that, which is, there we go, JavaScript SDK. So why JavaScript?
Oh, that's a great question, Josh. So we believe at Near that JavaScript is the language for mass adoption. Currently, around 20 million developers can currently read and write in JavaScript. And it makes onboarding very easy for the Web3 curious developers. They don't have to learn a new language like Solidity or Rust. They can just use what they know, use JavaScript, and get going with creating a full decentralized application. So you can build a full decentralized application from the ground up in one single familiar language. So yeah, with that, you can build, test, and deploy an application all in one stack with this new JavaScript SDK that we released.
So yeah, like what is the JavaScript stack? Near SDK.js is what you would use to build your JavaScript smart contract. Then you'd use what we call Workspaces.js. It's a framework in which you can test your smart contract before deployment, make sure everything works, and kind of like a virtual blockchain environment. We have Near CLI. Again, it's a JavaScript-based command line tool. It's a shell tool that allows you to build on Near and interact with it using Near API.js. And Near API.js is similar to Web3.js. It allows you to use JavaScript to interact with the blockchain, either wire your front end with it, or you can use Node.js and use Near API.js to interact with Near and manipulate state that way. And we also have Wallet Selector, which is one front-end library that allows you to have many different wallets that you want to use to connect with Near. Before, we had kind of like Near Wallet was like the wallet to use, but as the ecosystem is growing, we got about 40 different wallets that you can use on the platform. You can select Wallet Selector. We'll show you a little bit about that later. It's just a tool that you can use to allow your end users to use any wallet that they want. Cool. So yeah, workshop resources. If you'd like, here's the QR code. Take you to this link tree. We'll leave it up for just a second. It'll take you right to our presentation slides, the Getting Started guide, a workshop example project, the SDK repo, and then some help with developer office hours that I'll talk about more a little bit later. Also getting help on Discord, and then some feedback stuff. So yeah, I'll show this again in a moment. But yeah, if you want to go to pagoda.co/JS workshop, that'll take you directly there. Otherwise, you can scan this QR code. And with that, I think, yeah, we can break into a little bit of code. Dorian will do the honors and drive for a little bit.
Yeah. So the very first thing we want to show you guys is this nifty tool called Create Near App. So Create Near App will spin up a template for you to get started with your decentralized application development. Kind of similar to like Create React App in that way, where it gives you that whole nice like file structure. So the way it works is if I type in npx create-near-app and then do @latest.
Make sure we get the latest and greatest.
You get like a nice like selection of prompts to make this like whole sub process easier for you. So at Near, we have two different languages that you can write your smart contracts in. We have Rust and our JavaScript SDK. You see TypeScript here because we recommend writing your JavaScript, your smart contract JavaScript code in TypeScript because you can define your types and it makes for a much more secure and deliberate smart contract experience. So let's use that. And our front-end options are React.js. For those of you familiar with React, I am very comfortable with React. We also have vanilla JavaScript. And if you don't want a front-end to your application, you just want to write a smart contract, you can also choose no front-end. I'm going to choose React.js. And then you just give your project a name. So we actually already span up create React app just to be safe for the conference internet. So I'm going to cancel that, clear this, and just go over to. Oops, let's see. I have another tab open. Why is it not showing me? That's fine. Hello near. Code dot. And here is the actual file structure. So Josh, do you want to do a high-level explanation of these different files?
Yeah, totally. So this is, basically the template, the scaffolding for your project. It's broken down into basically 3 parts. You have your contract, your front end, and then integration tests. So if you want to go ahead and go to the contract portion of it, obviously you have your node modules with your dependencies. But if you go to source, you have contract TS, and this is it. This is an entire smart contract that you could use and deploy on Near. It's really simple. You have basic imports at the top. You have Near bindgen. Near is an object helper, call and view. Again, we're importing that from the SDK. And then we have that decorator Near bindgen at the top, and then view method and a call method. Looks very similar to something that you would use when just creating regular functions in JavaScript. Dorian, you want to take them through kind of a little bit more about what Near bindgen is and what all the decorators are here?
Yeah, so first off, we have our decorator Near bindgen. That's kind of like the glue that wraps your entire smart contract together and makes it readable for the Near blockchain to interpret. After that, we have your class instance. So this class will build up your state for your contract account. The state is going to be where you're going to be storing and retrieving information to and from the blockchain. And this first property here, we have greeting. Greeting is of type string because this is TypeScript, so we're defining a type of our property fields. And our default string will be hello for this message that's storing and retrieving a greeting. So then this first method here is what we call a view method. A view method on Near is a read-only method that pulls or queries information from the blockchain and delivers it to either your terminal, your console, or your application for your application to then manipulate. View methods are free. They don't incur any gas cost on you, so you can call them as much as you want. After that, we have our call method. And our call method, so a call method on Near is simply a way to store or modify existing information on the state of the blockchain, which incurs a gas fee. If you don't know what gas is, gas in blockchain is simply the cost of computation for a transaction. So this first method is called setGreeting, or this change method is called setGreeting, which has a property called message, and we're defining the type of that property called, we're defining the type of the parameter message as type string. You can see this call method is returning void, so it's returning nothing. We also have this cool little object called Near, which has a whole collection of tools that make your smart contract development easier. You can do things like get the current block height, get the name of the last account that signed the transaction and put it into your blockchain, into your smart contract, do things like get random seed and much, much more. The thing we're actually pulling from that Near object is just near.log. It's very similar to console.log if you're familiar with JavaScript, where it'll just take a string and return that string onto your terminal, your console, or and that's essentially it. So here the message we're returning is saving greeting and then whatever message you're passing in. After that, we are going to modify the state of the blockchain, and again, we're going to be doing that by changing the value of this property. So we have this.greeting and setting that to the new greeting. And again, that whole change will cost a gas fee, which is pretty minuscule. So if I were to run, let's see, yarn, or I'm sorry, I'll do npm. npm run deploy, you can do npm yarn, and hello near.
Basically, what we're doing right now is we're running a deploy. It's going to do 2 things. It's going to build this smart contract. It's taking this JavaScript. It's going to compile it. It's actually taking the TypeScript and it's going to compile it to JavaScript. So the TypeScript is actually more for you to develop and understand your types as you're developing your smart contract, and you can share this project with others. But yeah, ultimately, it's going to compile it down to JavaScript. And it's going to build a build folder that'll put the WASM in there. And Near is all based on WASM WASM WebAssembly. So everything's going to compile, whether it's Rust or JavaScript or assembly script. This will all be compiled to WASM, which Dorian's showing you. There's other files in this build contract if you want to dig into the guts, but these are all like these magic little code snippets that create this WASM from the smart contract that we wrote earlier. And what else happened in this build process is it did what's called a dev deploy. This creates an account for you. It deploys the count of the contract on that account. In Near, we have one contract per one account. And then it also is a faucet, gives 200 testnet Near to that account. So it does like all these things all in one. And if you want to dig into it, there's scripts on the side, build.sh and deploy.sh. That'll kind of show you the commands that we're running.
Yeah, and this is the actual dev account that Josh mentioned. So it's like this long thing of like strings and numbers. And if I were to actually click on this link, open. It's going to redirect you to this another tool, which is called the Explorer for Near. And this Explorer does a bunch of cool things of giving you information. So you can get information about a particular Near account name. You can get information about a transaction. And this particular transaction is that deployment action. So you can see that this deployment has succeeded. You can see how much gas it used to actually deploy a contract. If I were to click on the actual account name or the signed by name, you can get information about this dev account. You can see it's already preloaded with 200 test tokens. And you can also see that when it's been created, a new Flax's key has been created for this, and the contract deployment as well. So the Explorer is a really handy tool to get information about your account and your transactions. So let's see, goes back here, there we go. So now we have the dev account, and let's just do something. Let's just actually take the time to interact with the smart contract that we created. So if I were to open our terminal, move this over here for a minute, and make this bigger, is that good? Okay.
Cool.
Let's do Control Command K. So let's say I want to just retrieve this default message, right? We have this default message of hello. If I want to pull information from the blockchain and view it into my terminal, I'm going to have to call a view method. So I'm going to call this message get greeting. It has no parameters, so just keep that in mind. So if I type in near view, and then we're going to actually, before I even do that, I don't really want to have to type out that entire dev account name because it's kind of ridiculous. So if I do contract, there we go. If I make an environment variable called contract and save that to it, then this will make my life a lot easier. So if we do near view, then contract.
And this is Near CLI that we're using, the tool that we mentioned earlier in the JavaScript stack.
Mm-hmm. That's a good point. Yeah, so Near CLI, again, is a wrapper around Near API.js. It lets me interact with the Near blockchain from my terminal. It's very handy. So I have near view, so that means I'm calling a view method. I'm pulling information from the blockchain to this particular contract account. And I'm going to set the name of it, which I forgot, because I have the memory of a squirrel. So get greeting, and then I'm going to pass in my argument. So the Near blockchain, so when you work from the terminal, it accepts a stringified object as its way of interpreting its parameters. So in this case, again, we have no particular arguments for this method, so I'm just going to pass in an empty object, and that's it. So you can see I retrieved my hello string, so hey, got that one working. Awesome. Now let's say I want to change this, I want to modify this, right? So then I have to, instead of calling view, I have to call, right? So I'm going to type in near call, pass in my contract name, and then I think it's set greeting. And then let's go back. And we see that set greeting accepts the argument message, right? So let's keep that in mind. So we have set greeting. We're going to create our object instance again. We're going to do message. Nope, I did it wrong. So actually I have to put message in double quotes, and then put our value of that string also in double quotes. I'm going to put hello. Let's see.
Hello, Converge22.
Converge22.
Nice.
And then close that object, close the string. And then remember, so now this is going to incur a gas fee, right? So somebody needs to be, so some account needs to be able to pay for said gas fee. So we're going to actually specify the account that's going to pay for it and sign that transaction by putting in this flag called account ID. And then I'm just going to use my little, testing account, so blockhead.testnet. Again, go on YouTube and watch my series. That'd be great.
Shameless plug.
Shameless plug.
So yeah, it just called the blockchain, and that's done. It's finished. That was live. That was pretty quick.
Yeah, it was really fast. I'm kind of impressed.
Oh, one thing I want to point out real quick, because Dorian assigned it, he wrote blockhead.testnet, there's a step in here, it's a near login. He has a private key saved locally, and that allows you to sign these transactions. So that's a little step that, yeah, we can go over a little bit later and during Q&A. But yeah, just wanted to cover that if people were curious how we were able to sign that transaction.
That's a really good point. So yeah, when you do near login, it stores the Fluxus key onto your local machine and uses that Fluxus key to then sign your transaction. I'll go into Fluxus keys and this other thing called function called Fluxus keys a little bit later too. So yeah, again, if I click on this link, obviously we can go back to our Explorer, see that the transaction succeeded. We can see like the argument we passed in, and yeah, well, it looks pretty good. Oh gosh, see, I'm really bad at the command tab thing. And then let's see. So if I do, near view again, right? So 2 up arrows. So I have to type all that out again. You can see our message has changed. So it's changed the state of the blockchain, and now it's appearing here in my terminal. And something that's actually also pretty cool about, should we go to the front end? Should I open it up?
Yeah, totally. So yeah, that's basically it. That's deploying a smart contract, creating an account, writing a smart contract, and modifying the state. It's all done via the CLI. And yeah, we'll show you the front end a little bit. Did not dig into that too much, don't want to waste too much time, but just want to show you that, yeah, if you want to open up the front end, if you're familiar with React, again, standard kind of React outline with you have your app.js and index.js. If you click on wallet, we won't go too much in the weeds of what near wallet selector is. I can read more about it online, and yeah, we're happy to answer questions after the fact. But yeah, it's a library that allows you to kind of set up. You can see on lines 9 and 10. These are the wallets that you want to import, and you can select which ones that you want to. You can have your dApp have 1 wallet. You can have it have 10 or 40 wallets if you want, and it's all imported via this library. And then yeah, on line 8 we have a modal that pops up in the UI that we'll show you in a little bit. But yeah, if you want to go back and show them the near interface, here is some helper functions. You want to, yeah, there we go. We can prettier that, make it a little bit more readable. This is a class. It's a little bit new framework that we're playing around with, but yeah, basically helping us to define our helper functions, our get greeting and set greeting that we're going to use in the front end, and we're going to be passing a contract ID and what wallet we want to use. So we need that contract ID to know what the front end is going to use near API.js to contact, and then what wallet the user actually selected to use. So yeah, if you want to go to, I believe, app.js, we can show, actually index.js we can show real quick. Yeah, and this is where we're instantiating it. Hello near, let's prettier that, sweet. Break that down a little bit more. Yeah, so this on line 15, that's where we're instantiating the contract. It's using a local environment variable, and when you do a dev deploy, it saves that name and the access key right in your environment variable. So you could either pass on line 16 what the contract ID is, or it'll just grab your dev account, so you don't need to worry about what it actually is, and then which wallet that we're going to be using. And then on app.js, what I'd like to highlight here, it's a standard kind of React component. You have on line 16 in the use effect, so when the component's going to load, it's going to call get greeting. It's just going to fetch that state off the blockchain, and then once it gets that greeting, it's going to set it into the local state. And if you scroll down just a little bit more, on line 25, it's going to see, are you signed in? If you're not, let's direct people to click on a button that'll allow them to sign in with their wallet. Scroll down a little bit more, and then this is how we are updating the greeting on 34. Again, that hello near object that we created, we're going to call a method set greeting and get an input value from the front end. Then we will, reach out to the blockchain, modify that state, and then on line 35, we're going to again call get greeting, get the greeting back, and render it on the front end. So yeah, if you want to run a yarn start, I believe, which will do all the things. It'll compile your contract, it'll deploy the contract, it'll launch a front end, connect to that front end. Let's sign out real quick so we show them what it looks like when you first come to it. Cool, and because we already kind of interacted with the smart contract using the CLI, it's going to show you hello Converge22. But yeah, you want to show them signing in?
Yeah, So when you sign in, we'll show you our wallet selector. Right now, this wallet selector is particularly configured for only 2 options, My Near Wallet and Ledger. But as Josh said, there's many, many more options you can insert into the wallet selector as well. So I'm just going to go ahead and do My Near Wallet. And again, I have like Blockhead27. That's my, so just the account I'm signed in with on my Near Wallet. And so now it's redirecting me to the wallet website for a reason. So as I mentioned earlier, there are 2 types of like, what's really cool, it's really awesome about the Near ecosystem, and Near accounts in particular, is that we have 2 types of like access keys to your account. So we have full access keys, which will allow an application to have, well, full access to your account. With that, you can do things like create sub-accounts, which are just like, almost like subdomains for your account header. It'll have full access to all of your Near tokens. You can do things like deploy a contract onto your own account. And yeah, there's like much more you can do at that. And there's also like no limit on like how many times you can like make calls to other contract accounts as well. And then there are these things called function call access keys. Those are really cool because like function call access keys actually are like the same thing, but with like limited permissions or limited access to your account. One of the main things to take note of is that like with a function call access key, like an application does not have like, well, full access to your account or your tokens. In fact, it has an allotted budget of 0.25 Near. That's allotted specifically for gas fees. And so say you have an application that does like need access to your tokens, like if you're making like an application that sends money to your friend or something, or sends Near tokens to your friend, then in that case, the application will then be automatically redirected upon hitting like the send button back to the Near wallet, which does contain a full access key, which will then be used to sign that transaction, saying that it's okay to send your friend like X amount of tokens. And yeah, anything else? Oh yeah, with function call access keys, the developer can specify which methods, view or call methods that the application can call or the user can call from the application. Anything?
Yeah. No, it's basically just like having admin access versus a user access, and you can kind of scope those permissions down. It's a cool feature. You can have limitless amount of keys. You can have almost infinite amount of keys, and yeah, something happens in my private key, oh, it might have been compromised. I can rotate that out, get a new key. Same thing with function access keys. But yeah, go ahead and connect. And this is going to create a function access key on the account for this particular contract.
So I can change that to like hello world, hit save,
and now it's reaching out to the blockchain, and woo,
there we go.
Got the state and turn back hello world. Whee!
So you've integrated the contract into the front end.
And if you change it one more time, you'll notice kind of a cool part of like the function access key, again, is like I don't need to have my user constantly redirect and sign every single transaction. So they can do a bunch of different things without having to constantly, yes, I still want to approve it. Because there's no monetary value associated with it. There's no tokens being transferred. You can allow this to happen without you. Go to to the Near YouTube channel and check out more. Another shameless plug. Cool. Yeah, and there it goes. It modified the state and got it back.
So
cool. So yeah, we'd like to kind of take a moment to now show you how to do something a little bit more complex than just updating state. We're going to show you a game, a simple coin flipping game. And again, back on the link tree here, we're going to click on the workshop example project. And if you'd like to, it's this coinflip.js. You can clone it and run it on your machine with us if you'd like. Otherwise, we have it pre-cloned with the dependencies installed, so we don't have to make you watch that. But yeah, we'll go to coinflip.js and bring up the code. Cool. Let's show the file structure. Again, it's a nice README, takes you through it. But again, same style, collapse the, yeah. So same format. This was built using the Create Near app scaffolding. So we have the contract, the front end, integration tests. And then in the contract, we will show the source contract. And yeah, this is the smart contract for this coin flipping game. Same thing at the top. We're going to import near bindgen, near call view, a new thing called unordered map, which Dorian will go over. And then, yeah, in line 3, we're going to just have a side. It's going to be a coin flip, heads, tails, very simple. And then on line 5, we're going to simulate a coin flip. We're going to flip a coin. On line 7, we're going to get a random seed, and then we're going to show we're just logging it on line 8 for development purposes. And then on 11, using that random seed, we're going to find out if it's either a 0 or 1 and do heads or tails. Some people might be saying, why don't I just use math.random? You can't because blockchain. You basically it gives you the same thing over and over again. So what we're doing is using a utility called random seed that gets something from the current block height and makes sure that it truly is random. So yeah, if you want to take them through the rest of the smart contract.
Yeah, so again, this smart contract's a little more complicated than the other one, but still, fairly fun to follow along with. So, very first thing I want to show you guys is this type. So it's just a custom type here in TypeScript, which is defined to either heads or tails. So where that comes into play is this function here called simulate coin flip. So simulate coin flip is set to return type side, which means it has to return either heads or tails. Otherwise, we'll throw an error. And then the way we kind of randomize this by using this method in our near object called random seed. So that will generate random seed. And I'll show you guys what that ends up looking like as we run this function. And then with this random seed, which returns a random set of characters, a random string, it will then call character code at and use this modal to then either get a 1 or 0, which will then either correspond to a true or false, which will then correspond to either heads or tails. So again, we're playing a simulated coin flipping game. So if we're guessing heads and it turns out to be heads, then we get a point. If we guess heads and it turns out to be tails, then we lose a point. Next up, we have our old buddy near bindgen. Again, that's just the glue that wraps around our near contract and makes it readable for the near blockchain. And then I want to dive a little bit into this unordered map. So this unordered map is one of a list of what we call collections on near. And collections on near are simply just things that mimic data structures or familiar data structures. We have a collection for vectors, we have a collection for maps. And this particular one is just another map. So this is a type of collection that will store a key value pair, right? So if again, where in this case, the key is the name of the player or the account that's used that signed that transaction. In my case, it'll be blockhead.testnet or blockhead27.testnet as the key. And the value will be a numerical value showing the points that are associated with that name. After that, we have this beefy little function here called flipCoin. That's a change method. So remember, it's a call method. And remember, call methods incur gas fee as they either store or modify information that exists on the state of the blockchain. It has one parameter called player guess, and that player guess is of type side. So remember, it says TypeScript, so we have to define the type of our parameters and also the type of the output of our function. So we have so moving on line 25, we have the variable called player. And player is set to near and predecessor account ID. So predecessor account ID is simply a method that's going to return the name of the account that last signed the transaction. And we're going to be using that name as the key in our unordered map to keep track of our points. So again, this would just return blockhead.testnet if I call this particular method with blockhead.testnet. And then your log, again, it's just the same thing as console log. So it's just return this message that says, player, which is near predecessor account ID, which is just blockhead.testnet. So blockhead.testnet chose, whatever I guessed, either heads or tails, right? So player guess has to be heads or tails because it's of type side. Moving on, we have outcome. So outcome simply calls simulate coin flip, which will just simply output either the string heads or the string tails, as we showed earlier. And then next up, we have on line 32, we have player points. So player points we'll do as such. So it says this.points .get, from where .get came from. It's a method that's associated with this collection, with the unordered map. So .get using the player name as the key, and they'll either return a value if that account exists, and if that account does not exist, then it'll default to 0. And then it'll set that type as type number. So hopefully that makes sense. So again, if the account exists and you have a point associated with your account, it'll return a value, and if not, it'll just return a 0. And then now we have this conditional statement. This conditional statement will just check if the player guessed correctly or guessed incorrectly, and then adjust the total point value, total score value for that player automatically. So it says if player guess is equal to the outcome, meaning like Dorian guessed heads and the outcome was also heads, then I get a point. Here it says, near log, the result was heads, you get a point. And it just takes the existing point value and adds 1 to that existing point value. So if it's 5, then it'll be 6. Otherwise, if Dorian guessed wrongs, in other words, if Dorian guessed heads and the outcome was tails, then I will lose a point. Or if I don't have any points to even begin with, this like tertiary statement will just set my, or ternary, I always get that name wrong. Well, it will just keep the value at 0. So this entire line is set such that my total score will never go below 0, so I don't get any negative points.
We don't want to be mean.
We don't want to be mean, we just want to be nice. It's a fun game. So then after that, we'll take that, all that like existing point value and store it on chain by doing this.points.set. So again, points is an unordered map, which comes with this nifty little method called set, which should then allow you to specify the key, which is my player name, blockhead.testnet, and then the point value, right? And it'll just update that point value and set the new point value to that player in our unordered map. And then it'll also return the outcome as well, so you can verify that we're not cheating. And we also have this cool little view method just to view like how many points a specific player has. So unlike our other view method in our example earlier, this one actually does accept a parameter, and that parameter is player, and that player is of type string, and this is TypeScript. So again, we have to set the output, and that output is a number. So we have our points, which is set to this.points.get, which is going to retrieve either the points from that player. If that player doesn't exist, then it will return a 0. Then it'll simply log that value, that message saying points for Dorian is either 0 or 32 because I'm a lucky guy. And then after that, it'll just simply return that points value, and you can modify that in your application or view it in your terminal and/or console. Yeah.
Cool.
It's our smart contract in a whole.
Let's have some fun. Let's compile it and deploy it to the blockchain.
Let's do yarn, oh gosh, if I can spell. Yarn deploy.
Cool, so again, it's gonna go through this, compiling it, creating a WASM file, creating a new dev account, spinning that out, funding it, doing all this stuff so you don't have to in the background, and then deploying the smart contract on that newly created account and paying for it. And then also like storing all the credentials again in the environment variable directory. Cool, so it looks like it went through, it worked, awesome. We got a new smart contract on the blockchain. Now, let's play the game.
So
the moment you've all been waiting for.
So much fun. Let's play a game. This game is called Coin Flip.
This game's called Coin Flip.
And I'm going to, let's take a hand. Let's take a guess.
How many people want heads?
Raise your hand if you want heads.
Okay, well, 1, 2, 3, 4, 5, 6, 7, 8. All right, tails?
Oh my God.
I see some of the same hands. You guys are cheating. 4, 5, 6, 7. 7 and 7. Now we have to coin flip to see.
We have to coin flip to choose which
to choose the coin flip. Let's go heads.
Let's go heads. So it'll be near, call, and then, did I do that? No, I didn't.
You gotta do the contract variable.
Memory.
Makes it a lot easier than having to remember that string, or at least copy paste that string every time.
Speaking of memory, I still have the memory of a squirrel or chipmunk. What's it called? It's called, oh my gosh.
We are going to call flip
coin, right?
Flip coin.
There it is, yeah. Flip coin, which accepts a parameter, which is the player guess. So we're going to do flip underscore coin, then stringify my object, which is, what was it? I forget, player guess, see? Chipmunk.
In quotes.
Oh my gosh. Player guess. And then what would you say?
I think we said heads. I think we're going with heads this time. All right.
And then remember this is a change method, so we have to sign this transaction. So we're going to do flag account ID. Let's just do blockhead. Yeah, that's fine. .testnet.
Cool.
Drum roll.
We got tails. Oh, we lost the point.
Lost the point.
Who
Who guessed Tails? I want to know who guessed Tails.
We should have went with those guys. Man, all right.
Okay, you're cool.
All right, one more. Let's try one more time. Let's do it one more time. Let's do heads.
Drum roll.
Random seed. Come on, random seed.
Oh, we got a point.
Oh, we won! All right, we got
tail.
a point. Oh, awesome. Cool. So now we can view the state. So if you want to call the contract and then view the number, we should have a point now associated with our account.
I think it's points of.
Actually worked well.
Yeah, so points of, which accepts the parameter of player. So I'm going to put blockhead.testnet as that. So points, is it points? Yeah, points of.
And then the player. The first time we did this was at was a Consensus in Texas, and it was literally like 10 losses in a row, and it was just like, but then we finally won. And that makes
So we're
sense.
feeling luckier today. It's good.
Yeah, we are feeling
Good.
pretty lucky today.
Lucky to be here. It's good.
Nice. Cool. Awesome. Cool. We got a point. Awesome. Let's show them the front end.
Yeah.
So yeah, basically, we can do yarn start. You got the front end already built in, same way in which we were interacting with it before. Cool. We got a little coin flip. I don't know if Ilya's in here now, but we put his head on there. It's the co-founder. We threw it on there and thought it'd be funny. So yeah, let's sign in with our Near wallet. And that's, again, this is going to create this function access key. And again, we'll kind of illustrate why function access key is cool, because we can keep playing the game, but we don't have to constantly do our wallet redirect and sign a transaction every time, because we're just playing a game. We're not doing tokens. So let's go heads, tails. Who do we want? Heads, tails? Just shout it out. Who?
Head.
Oh. Tail heads, tails.
I feel like
I think we have more tails on this time.
We're gonna do
So
tails.
tails.
Tails or Ilya? Ooh.
Oh, we
Heads
got
it.
Ilya. We got Ilya.
We got Ilya.
All right. Yeah,
Will Ilya
forsaken.
will Ilya be kind to us?
All right, heads.
I'm gonna get fired. I swear.
Oh, I'm not going to Vegas today.
my gosh.
Let's try one more. Let's try one more Ilya. We should name the button Ilya or Tails.
We got Ilya.
Oh, we got Ilya. Nice, cool. So yeah, it's very tongue-in-cheek, obviously, but just a really simple way to create a game, create something in JavaScript. It's super simple, super easy to use, and yeah, that's kind of our presentation. You want to go back to the slides? Yeah, so again, go to the next one. Some people that may have forgotten, this is the QR code for the JavaScript workshop. If you want to take a scan of that or you want to go there, we have the link tree, everything that we did, the repo, all of the things in there, including DevRel office hours and help on Discord, which I'll go over in a second. You want to go into the next slide. Feedback and suggestions. This is a new SDK for us. It's something that we've created, obviously, to onboard a lot of users, and we want to get feedback from it. So we want to drive that discussion in the GitHub repo. So please go to the repo, give us general feedback on your experience using this SDK. Any improvements or suggestions that you might have. And even, there's an area in the bottom, show and tell. Show us your project. What'd you make with it? Let us know. Say, hey, I made this cool thing. Show it off. And it'd be awesome to see what you guys make with this. Any issues or bugs, we're trying to fix them. We're trying to make the developer experience as easy as possible, make this really production ready for mainnet. So got any issues, please file them in the repo themselves so we can kind of triage those issues and make sure we squash these bugs and make the developer experience really smooth for everyone. And again, need help, near.chat is our Discord. We do a lot of developer support there. We're answering questions all the time. And if you want, you can actually ask a dev during our daily office hours. It's something that's really cool at Near. We have office hours daily twice a day in the morning. I have folks in Europe on the developer relations team that join Discord. You can hang out, ask a question. You can share your screen. We'll troubleshoot live with you for an hour. Same thing in the evening in America time zone. We'll more than happy to have you ask ask any question, developer question, non-related. Again, that's every day. If you go to near.org/office hours, you can just add this to your calendar. It'll automatically put it in there. And then, every Friday, Vadim, for our Russian-speaking community, has office hours as well to help out with them. And pretty soon coming up, we're going to have protocol office hours. So if you have any questions about the protocol, you want to talk to the core team and find out more about sharding or anything really you want to ask, we're going to be doing that weekly as well. So near.org/office hours is the place to go. And then, thank you so much. We super appreciate you you going through a technical presentation. Sometimes it's kind of a little boring, but I appreciate everyone's time today. Super stoked on it. Have any questions, please let us know. But yeah, if anybody, I think we have a couple minutes to maybe answer any questions if some people have some. I believe there's a mic kind of floating around here.
Right here, actually.
Oh, is it over here?
Yeah.
Cool. Dorian, do you want to hand that mic to someone out there in the...
You have to come up.
Hey, Noah, can you give that mic to that person right there?
Thank you.
Thank you. Come on down. All right, I'm going to have to... They're really blinding me.
Yeah, no problem. First of all, thank you guys so much for showing us that. That was awesome.
Cool.
What has your team done to kind of mitigate the risks and security that come with using kind of a loosey-goosey language like
JavaScript?
Yeah.
Yeah. So step one, TypeScript.
Yeah, right.
That was our first thing.
Besides TypeScript.
First step one, all right, we need types. It's definitely what we want to start out with. The goal is definitely to have it to that level. It's never going to be, I hate to say it, but as secure as Rust would be, but it's just Rust is this thing that, intimidates people. It intimidated me, and then you're like, oh, it's actually not that bad. So this is really meant to kind of bring people into the ecosystem and show them it's not that scary to get into. But yeah, I definitely, having someone kind of audit your smart contract, definitely joining the office hours and we don't audit your contracts for you, but we can definitely say, hey, this might be not a best pattern that you want to explore here. I would say for DeFi projects or stuff like that, you might want to stick with Rust until JavaScript or TypeScript gets to that that level of maturity. But yeah, that's a good question. Will it ever match Rust? Will it ever be as securely typed and stuff? But yeah, because Rust, it's oh wow, it screams at you. You just try to develop on it. It's oh, you forgot an ampersand, and it's really explicit that way. Mm-hmm. But yeah, we're doing our best to kind of address some of those concerns, and yeah, it's really meant to be kind of an entryway into the space. And not right now at least. We don't recommend it for financial use applications at the time.
Thank you.
Yeah, absolutely. You want to pass that mic to the individual behind you?
Yeah, thank you guys for the presentation. This is kind of a very specific question, but for your collections.
Yeah.
Is it possible to write a view method that returns the entire collection at once?
Totally, yeah. We just had that one, method that will return it. There is a limitation to how much data you can get through a call, so you have to implement some sort of pagination. But yeah, you could definitely do something where you're getting, a
chunk of it.
A chunk of data or a blob of data. You again are limited to a certain amount, and I'm not sure how many kilobytes it is per call. But yeah, you are limited per call, so you'd have to do some pagination, but you can definitely get more than just one key value pair.
Awesome, thank you.
Cool, yeah.
I actually ran into that with Solidity recently, and it's you got to just loop through every single one, and I'm okay. Well,
yeah, no, that would take,
There's 100,000.
yeah, no, that would take forever.
Yeah.
Totally. Yeah, cool. Any other questions? Any other burning questions? Oh, we got one brave soul in the back there.
Hello, and thank you for the presentation. I was just curious how all of this is, if you can show this, obviously, how all of this is represented in the blockchain. So is there, I don't know, is it tightly coupled with how you write the contract? Or, if you have a variable and it's changing all the time, is it just creating, the different states of that variable in the blockchain, or is it more complex than that?
I'm sorry, I'm having a hard time parsing that. You're saying how is what we just showed you?
How is it represented in the blockchain? So it's kind of behind the scenes what's going on. It's more of a curiosity question.
Oh, how we're actually deploying it on? How we're actually deploying?
How a contract is represented on the blockchain, for example.
How are contracts represented on the blockchain?
Yeah, kind of I think maybe like into the sharding mechanism or like the underlying like mechanisms, like how it works, right? Like how information is stored, like with the block.
It's kind of curious to understand how it works.
Yeah. So yeah, there's like state per contract. So you have like the account model is you have one account per smart contract, you deploy an account or a smart contract to that account, and then the state is kind of like separate from it. It's in the transaction, so like as in each block you can submit your smart contract, it's in there, but there's also this thing called like garbage collection. So after like, I think it's like 3 epochs, which is like 3 days or maybe it's like 72 hours. I'm not exactly 100% on that. It gets garbage collected. It's still on the blockchain as far as there's archival nodes that'll retrieve that data. But as far as like the current state, you got to pay. We didn't really get into it, but this mechanism called storage staking. So you have a little bit of near that's on the validator, and they maintain the current state for you. So as you like add more key value pairs to your smart contract, you got to have a little bit of more near to hold that state. So yeah, there's a whole like protocol, and then like the contract runtime. It spins up this virtual machine. WASM runs the smart contract, spins down, executes some code. I'm not sure. Is that kind of answering your question? Or?
No, it was just a curiosity question. Of course, I'm not going tomorrow and write near from scratch, but it was nice. Thank you.
Okay, yeah, no problem. Yeah, and feel free to hit me up afterwards, and if I didn't clarify, if I didn't, get to the meat of that question, happy to clarify.
Something look up the state of like one of these accounts, but I think mine was empty.
Okay. Well, we'll view state of the contract.
Oh, that's fair. Yeah, contract.
Yeah, there you go. Here's your key value pairs right there. It's all in base 64 encoded, so you'd have to like decode, and near API.js kind of handles that. So you have like a key, it's base 64 encoded, and then the value, again, base 64 encoded. You have to uncode that, but that's a CLI command that'll kind of show you brief state. Any other questions? Oh, we got one in the back. Is that you in the back, or are you just waving goodbye? Oh, you have a question, cool.
Oh, okay, cool.
Hi.
Hey.
Thanks for your presentation. So those limited accounts that have limited functionality, I think you called them function applications.
Oh, you're talking about like the function access keys? Yeah, the access keys, yeah.
My question is, what tools do you use to provision those? Is it in the CLI? Is it in your wallet?
How do you create those function access keys? Yeah, so like the wallet itself like defaults to 0.25 near, and it's gonna call just this contract. But you can like programmatically create access keys. You create like a key value pair. You're like, all right, actually I wanna give this key like 1 near. Because after it uses that 0.25 near from all those gas transactions, the key's spent, you can't top it back up.
Oh, okay.
So programmatically I can use near API.js, and I can code, I'm gonna create a new key. This key can call this smart contract, and it can call this method on this smart contract. You can get real specific with it. But near wallet has kind of like a default, but again, near wallet's like built using near API.js. It's kind of using its primitives there. So, but yeah, you can use like Node.js, or you can, I think you can use near CLI to actually create a key, specify some of these things. Or yeah, you can run a Node script using near API.js to like programmatically. And this is all in our documentation, docs.near.org.
Great, thank you.
Yeah.
Can I show the screen too for a hot minute? That's like a...
Oh, you're showing the different keys?
Yeah, I just want to show what it looks like in the
Gotcha.
CLI. Is that gonna pop up? There we go.
There you
Okay, thank you. Yeah, so like one, I just ran this command called near keys, and then the name of my account, which is blockhead.testnet. You can actually see like all these like different types of keys that are created for all these various types of accounts. And then like the way like it's like differentiated is by just like their definition of this like permission field. So you can see like the permission for this one's full access. So this is an example of like a full access key, and below it we have like example contract.testnet for like a function call access key, how much allowance it has left. You can see I never actually like made any change methods or change calls to this one because it still has a full 0.25 near on it. And yeah, like Josh said, you can use near API just to create a new key. You can use your near wallet when you're signing into an account to create a new key. You can use like near CLI to create another key. As you can make again, and you can also make like multiple like full access keys too, right? So I can, if this one gets compromised for whatever reason, I can make a 3 or however many more I want.
Yeah, it's almost infinite amount of keys.
Until you run out of money.
Yeah, until you run out of money. Cool. Well, thank you so much, everyone. If you have any more questions, Dorian and I will be around. We'll hang out for a little bit. Come talk to us. If you don't see us here, go to near.chat, reach out to us there, come to the office hours. We're there all the time, super accessible, and would love to help answer any questions you have on the information that we presented today. So thank you very much.